Hello, welcome to College Algebra, section 12.2. My name is Rob Reynolds, and today we're going to be looking at systems of linear equations, matrices, similar to 12.1, but 12.1 we were not supposed to be using a calculator. I did. We looked at substitution method, linear combination method, but I also looked at the calculator method. So you may want to look at 12.1. This will be a short lesson because I've already kind of taught the calculator, but basically it's just trying to take a system and write it into an augmented matrix. You can see all they're doing is taking the coefficients of your x's and y's and and your answers and write it into a matrix. Again, this would be row 1, and this would be row 2, column 1, column 2, and column 3. So we would call this a 2 by 3 matrix. It's always a row by column matrix. Rows go left and right, so 2 rows. Columns, C-O-L-U-M-N. You can talk about the elements of the matrix. This means row 1, column 1. So this is the element row 1, column 2. This would be row something I. Maybe it's row 3 or row 4, but it's column 2. So we usually just generally say I and J. So I is the row, and then J is the column. So you can make it as big as you'd like. So to solve writing the augmented matrix, this would be 2 rows by 3 column, and this would be 3 rows by 4 columns. So here it's written for you. And if there's any zeros, such as the second row doesn't have a y value in it, then they'll place a 0 in. The third column, there's no z. In fact, I would probably take the -8 and throw it over and rewrite this. X plus 2y plus no z's is equal to 8. And that way you can get a positive 8 on this side and no z's. So be careful because it may not be in standard form for you to dump it into a matrix. We can also go backwards and we can write this as a system. So given an augmented matrix, to write the system 5x plus 2y is equal to 13, negative 3x plus y is equal to negative 10. Again, my full notes are on Blackboard. Feel free to look at the PowerPoints. There's row operations. This says multiply row 1 by -3, so -3 times row 1, and then add it to row 2. So I'll take row 1 and multiply everything through by -3, changing this 1 to -3, followed by a 6, then a -6, and it says just don't do anything to row 2, so I'll just rewrite row 2. 3, -5, 9. And it tells me to add them, so adding straight down, I'll get 0, 1, and 3. If I rewrite this, the only row that changes is the row that we're changing. So we have a new row 2, so nothing happens to row 1. So 1, -2, 2 stays the same, and my new row 2 is right here in green. And I'll just transfer that down here, 0, 1, and 3. Again, the only row that changes is the row that we're changing. And I was trying to probably zero out this guy in row 2, column 1. That's the element here. And again, you don't know this, but the purpose of probably trying to zero out this guy right here is because I probably want to get it to an identity matrix. And the identity matrix means I continue doing these row operations till I get it down to this 1, 0, 0, 1. That's the identity matrix. Because then my answers would be here. The x value would be here and the y value would be here, because if I read this, this says 1x, no y's equals whatever that answer is for x, and this would be the y value. 1y equals whatever that answer is. So the goal is to get it into this form. So the bottom equation says no x plus 1y equals 3. And once you know that y equals 3, you can plug it into that top equation, which reads, what does this read? X minus 2y equals 2. So I'll throw the y in here. So x minus 2 times that 3 that we found from the bottom equation. X minus 6 is 2, so x is 8. So quick way to solve using matrices. More row operations. This says negative 3 times row 1 and add it to row 2. By multiplying row 1 by negative 3, I come up with negative 3, 9, negative 12, negative 9, and add it to row 2, which is a 3, negative 5, 6, and 6. My new row 2 is going to be 0, 4, 6, and 3. So again, the only row that changes is the row that we're changing. We have a new row 2. So I'll rewrite 1, negative 3, 4, 3. I've got my new row 2, 0, 4, 6, and 3. But it does look like I'm trying to change row 3 as well. So let's just create a new. It says take 5 times row 1. So here's row 1. I'll take 5 times it. So 5 times row 1 gives me 5, negative 15, 20, 15. And add row 3 to it, which is here. Negative 5, 3, 4, and 6. And adding 0, negative 12, 24, and 21. By the way, I think this divides by at least 3. So when I bring this over, I'll divide everything through by 3. I get 0, negative 4, 8, and 7. It just makes the numbers a little bit smaller. Remember, this is a systems of equation, and you can simplify. You'll see the author did not do that, but I certainly would recommend it. Solving by systems, row echelon form says just get this row of diagonals in here, and then you could back sub because you've solved already for this. Remember, this is your x's, this is your y. So this would say z is equal to whatever this number is, and then you could back sub, solve for your y and solve for your x. Here's the book's rules and definition. So it says use matrices, and they want you to work this out by hand, but honestly, if I saw this on my math lab, I would go to my calculator. So just show you real quick, I would edit this. This is a 3 by 4 matrix. So type in the dimensions, 3 by 4. 2, 2, remember we have a 0 in here, 6, 1, 1, 1, 1 for this entire row, 3, 4, negative 1, and 13. Go under matrix, math. You can choose row echelon form, which is A, but if you just want to get the answer and do, sorry, I forgot to do quit. So hit second quit, then go to your matrix math. I'm just going to choose reduce row echelon. Pull up matrix A for the third time. And you can see it gives me nice answers. 1, 2, and negative 2. But if they ask for just echelon, they just want this row of diagonals to be 1. And so working this out, you can see they're going to say z equals negative 2, and they're going to back sub that into this equation, which says y minus 4z is equal to 10. And then they'll plug that z value in, so y minus 4 times the negative 2 equals 10. When y plus 8 equals 10, or y equals 2, then they'll take the y and the z and they'll plug it back into the top equation, or the original equation, and eventually get the final solution, x is 1. So they'll write it in x, y, z form. Again, here's the book's notes. You can pause the video. To get this into row echelon form, remember none of these stars matter. Your goal is just to zero this out first, then zero this guy, then 0 this guy, and try to go for the 1s. But honestly, I would go to the calculator. But if you want to 0 this guy out here, I'd multiply the top row by -2 and add it to row 2 to come up with a new row 2. So -2, 2, -2, -16. Row 2 is 2, 3, -1, -2. So my new row 2, 0, 5, -3, -18. I can't reduce that. So you can see the only row that changes is the row that I'm changing. So I don't do anything to row 1, but I did get a 0 where I wanted it. 5, -3, -18. My next goal would be to 0 out that 3. And I can do that by multiplying row 1 by -3 and adding it to row 3 to come up with a new row 3. So I'll do this one more time. -3, 3, -3, -24, row 3, and then I add, and I place that row here, and I continue with this process until I get this row of diagonals here, and then I back sub. Reduce row echelon says get all the 1s, and you can see this is a 1, 0, 0, which just means x is 4, y is -3, and z is 1. Again, you can do that on your calculator. If it's dependent, that means there's infinitely many solutions, and if there is infinitely many solutions, you need to write the solutions in terms of the other variables. Usually z is the parameter. So I'll show you how to read this off your calculator. Again, I'm going to go a 3 by 4 matrix. I'll grab the coefficients. And I need to quit. Sometimes I forget to do that. Second matrix. Again, reduce row echelon form. B, second matrix, call up matrix A, and I'll hit math, enter, and it will clean this up a little bit. But you can see the denominator is 0, 0. I'll copy this. A little bit difficult to read. So to read this, I can see it's a true statement. That's what dependent. I'm going to end up with, because 0 does equal 0. Let's continue writing this. This top equation says x plus 2/11 z is equal to 7/11. So solving for x, I would say x is -2/11 z plus 7/11. And then when I write the equation, I'll just put that here, -2/11 z plus 7/11. I'll let z be the parameter, and I still need to solve for y. And y comes from row 2, where it says y minus 1/11 z is equal to -2/11, or y is equal to 1/11 z minus 2/11, and I'll place that here. The author went through and solved this by hand, but I believe got the same solution. Looks good. There it is. All right. This is just a larger matrix. I would do the same thing, reduce ratio, and then story problems. All right. If you have additional questions, I would go to Blackboard. Again, look at the PDF files that are posted on Blackboard, or feel free to email me for further explanations. Hope this helps. Bye.